So today's factoring technique is going to be with trinomials, and this is what I otherwise call the squiggle method. And this will be our first example. So we definitely also want to review a couple of the other techniques that we did in our last lesson. We still want to continue to look for GCFs in the beginning, and I don't see a GCF in this particular one. The constant doesn't have, an X next to it, so I don't think there's any GCF that we have to worry about in this one, but we're going to continue to look for GCFs in the problems that we do later on as well. So with the squiggle method, when we factor trinomials, 3 terms, we bring down the first term, we bring down the last term, and then I do a little squiggle on the side. And what we're going to do is we're going to multiply those 2 terms that we just brought down. X to the 4th times negative 4 is negative 4x to the 4th. And what we want to do now is we want to think about negative 4x to the 4th in a couple of ways. We want to break it down so that the factors multiply to be negative 4x to the 4th, but add to be negative 3x squared. So first and foremost, x to the 4th, we're going to be breaking down as x squared. We always want to break it down evenly. And then what multiplies to be negative 4 but adds to be negative 3? So that would be negative 4 and positive 1. And then we're going to insert those 2 terms in the center here. And then we do factor by grouping. So in the first group, I can see that there is a GCF of x squared, right? We want to steal the lower of the 2 exponents. And if we divide these 2 terms by our GCF, we will get x squared minus 4 in our parentheses. Now when you do factor by grouping, your goal is to get identical parentheses. So I'm going to go over here and copy and paste x squared minus 4 and essentially just think backwards. What should I have factored out here so that I can achieve the x squared minus 4? Well, since I already have x squared minus 4 in my parentheses here, that would imply that really I would just factor out a positive 1. So in our next step, we now have x squared minus 4 in both parentheses, which means it's our new GCF. So we bring x squared minus 4 down once. And then x squared plus 1 in the other parentheses. And then we want to ask ourselves, can any of these parentheses be broken down any further? And I do see that x squared minus 4 is difference of 2 squares. So we're going to break down this as x plus 2, x minus 2. X squared plus 1 is not difference of 2 squares because of the addition symbol. X squared and 1 are perfect squares, but remember you need to have subtraction as your sign. So this really would just be our final answer here. Okay, example number 2. X to the 9th minus 4x to the 5th minus 32x. So unlike example 1 where there was no greatest common factor, we do have a greatest common factor here. If you take a look, we have x to the 9th in our first term, we have x to the 5th in our second term, and we have x basically to the first in our last term. So if we remember the technique of factoring out a greatest common factor, right, we want to steal the lower of the exponents. So the GCF is really going to be x to the first, or simply just x. So now if we consider what should be in the parentheses, we're technically just dividing each of these terms by our GCF of x. So this is going to give us x to the 8th minus 4x to the 4th minus just 32. And now we can focus on the parentheses, our trinomial, and do our squiggle method. So we're going to bring down the first term. We're going to bring down the last term, and we're going to do a little squiggle, and we're going to multiply those two terms. So x to the 8th times negative 32 is negative 32x to the 8th. So now we have to consider what multiplies to be negative 32x to the 8th, and what adds to be negative 4x to the 4th. So first we'll break up x to the 8th as x to the 4th times x to the 4th. And then it looks like we'll have a negative 8 and a 4. Negative 8 times 4 is negative 32. Negative 8 plus 4 is negative 4. So that seems to work out. So those two terms will go in the center. And then we'll do our factor by grouping. So in our first group, again, we're stealing the lower of the two exponents for our GCF. So x to the 4th will be our GCF. And that's going to leave us with x to the 4th minus 8. Copy and paste your parentheses that you want. And then think backwards here. So something would have had to be factored out such that you would get 4x to the 4th minus 32. So I believe we would have to have a positive 4, right? Positive 4 times x to the 4th gives us 4x to the 4th, and 4 times negative 8 gives us negative 32. So I think that's how our setup has to be. So we take our identical parentheses as our new GCF. And then in the other parentheses is all of the stuff that was sort of outside of the parentheses. Okay. And a common mistake here is that students would forget about the original GCF of x that we took out in the very, very, very beginning. So we want to make sure that we always drop that down and we don't forget about it. Okay. And now what we want to ask ourselves is, do we have any dots? So I'm going to do dots, question mark, dots, question mark. So let's consider x to the 4th plus 4. X to the 4th and 4 are both perfect squares, but again, we have this addition here, and for different to 2 squares, you need subtraction. So right away, I can see that x to the 4th plus 4 is going to be left as it is. So now I go over to x to the 4th minus 8. I have the subtraction, which I want, and now I have to just consider what is the square root of x to the 4th and what is the square root of 8, and are they perfect? And we know that the square root of x to the 4th is x squared, but the square root of 8 is an irrational number. So this also does not fit into difference of 2 squares. So our final answer really is just this. Okay, and we're going to do one more for good measure. So this is number 3. So we're going to have 2x to the 14th minus 19x to the 8th plus 9x squared. So in this trinomial, I definitely see that there's going to be some sort of GCF because we have x to the 14th, x to the 8th, and x squared. So stilling the lower of the exponents will be x squared. You also want to make sure you consider the coefficients too, although I don't think that there will be a greatest common factor between 2, 19, and 9. So I think it's just the x squared that we have to factor out. So we just have to consider dividing each of these terms by x squared. So that's going to give us 2x to the 12th minus 19x to the 6th plus 9. So focusing on our squiggle method inside, we're going to bring down 2x to the 12th. We'll bring down positive 9, squiggle it out. 2x to the 12th times 9 is 18x to the 12th. All right, so we've got to figure out a way to factor this so that we multiply to be 18x to the 12th, but add to be negative 19x to the 6th. So first, we break it up, x to the 6th, x to the 6th. So what multiplies to be 18 but adds to be negative 19? So that would be negative 18 and negative 1. So those two terms are going to go in the center here. And then we factor by grouping. So in the first group, we have a GCF of 2x to the 6th. And that would leave us with x to the 6th minus 9 in parentheses. So we're going to copy and paste x to the 6th minus 9 in our second group. And it looks like we would have had to factor out a negative 1, right? Because we would want to ensure that we get negative x to the 6th plus 9 if we were to distribute. And we would get that negative 1 times x to the 6th is in fact negative x to the 6th. And negative 1 times negative 9 is positive 9. So that looks like the proper setup. So in our next line, we're going to bring down our identical parentheses, which is our new GCF just one time. And then 2x to the 6th minus 1 in our next parentheses. We don't want to forget about the original x squared GCF that we factored out in the very beginning. So we want to make sure we include that here. And now we have to consider, do we have any dots? So dots, question mark, dots, question mark. Okay. And if we look at x to the 6th minus 9, and we consider what the square root of each of those sides are, it's perfect. The square root of x to the 6th is x to the 3rd, and the square root of 9 is 3. And we also have subtraction. So yes, x to the 6th minus 9 falls into the category of dots, difference of two squares. So that's going to be x to the 3rd plus 3, x to the 3rd minus 3. And for the second parentheses, 2x to the 6th minus 1, we do have subtraction. But then we have to consider, can we find the perfect square roots of 2x to the 6th and 1? Of course, the square root of 1 is 1, but we have a little bit of a problem here because the square root of 2, although the square root of x to the 6th is in fact x to the 3rd, the square root of 2 is irrational. So 2x to the 6th minus 1 does not fall in the difference of two squares category. So we're simply just going to drop that down into our answer.